With proof by contradiction, we need to first look at how you decide what the statement should be. So this is called negating the original statement, and there's 3 examples here on your screen. So the first example says there are infinitely many prime numbers. Yeah, they don't end. They just go on and on and on. So what is the negation of this? What is the not case? There are infinitely many non-prime numbers. There are finitely many prime numbers. There are finitely many non-composite numbers. So this is just to confuse you. What's the opposite? Sorry, not the opposite. What's the not case? Well, there are not infinitely many prime numbers. In other words, there's a limited number. So the statement we're looking for is that there are a finite number. Let's do another one. So if the statement was something like all popes are Catholic, okay, this is maths. I know it's a bit regarding logic and so on, but this is still maths, okay? So if it says all popes are Catholic, what's the not case? Well, it's sort of not all popes are Catholic, isn't it? Because that's a very strong statement to say all. So there exists a pope who is not Catholic. No popes are Catholic. I am the pope. Hopefully you can see that it's the first statement that we're going for. Okay? And the last one, which is really much closer to examples we'll be dealing with. If it is raining, my garden is wet. So I would encourage you to think about it like this. So the statement is saying A. If it is raining, that's like A. If A, then my garden is wet, then B. So if we're going to negate this, we should explore when A does not lead to B. So which of these statements does that? It is not raining and my garden is dry. Well, that's sort of like not A, isn't it? We want to start with A and say that it does not lead to B. It is not raining and my garden is wet. So, okay, that's kind of the same thing as before, except they've changed dry and wet. But again, they're looking at A, aren't they? We want to explore the case that A does not lead to B. So if it is raining, yeah? The if it is raining part is what we want to explore. So if it is raining and my garden is not wet. So this is really the same, isn't it? It is raining and my garden is not wet. This is like not B. So this is the option that we're picking. And it is a bit tricky to get your head around. But if you have if and then statements or something that looks similar, the key is to keep the if statement and then to explore that it's not B. Okay, I've put an example on the board there about odd and even, and this is a very, very common one that's used. So we're going to do this now with like an actual sort of exam type question. So this is what it looks like. It says, prove by contradiction that if n squared is even, then a must be even. So what's the a part? The a part is the bit that comes after the if, isn't it? So n squared is even. That's the bit that's going to stay the same. Then n must be even. That's the b part. So we're going to look at the case that not n must be even. And I would say to you, well, what is not even? It's odd, isn't it? So our assumption, assume there is some number n so that n squared is even. In other words, so that a stays the same. This is a bit wordy, but don't worry too much about that. The key bit here is, but n is not even. So in the next video, we're going to have a look at what the full proof for this will look like.